Hi everyone. Today we are going to discuss logarithms based problems, daily practice problems, part 2. So here I have some questions so that I'm going to discuss in this video. So please support to my channel and please see the full video. And first of all, thank you for all for supporting my channel. So 1000 subscribers I reached. So thanks for your wonderful support and keep supporting me and keep forward to your friends to use these videos to crack the JE mains and advanced. Let's start today's video. The question is if log x minus y minus log phi minus 1 by 2 log x minus 1 by 2 log y is equal to 0, then x by y plus y by x is equal to what? So this is our question. So let's see the solution for this one. So first what they are given is log x minus y minus log phi minus 1 by 2 log x minus 1 by 2 log y is equal to 0. So this is equal to log of x minus y. So from these first log minus log phi, let it be. So from these two I'll take minus 1 by 2 common. So what I will get log x plus log y I will get. This is equal to 0. So this I can write like log x minus y minus log phi. Just to take this one minus 1 by 2 log m plus log n formula I can apply here. Log m plus log n is equal to log mn. So base conditions always apply. So this will get log xy is equal to 0. This is equal to let's take the LCM of this. So I'll get 2 log x minus y minus 2 log phi minus log xy is equal to 0. So what we will get next? So this is equal to, we can write this one as log of x minus y whole square minus log phi square minus log xy is equal to 0. So for these two again, I'll apply log m minus, if I'll take common log m plus log n, it will become, so which can be written as log m into n. So according to this formula, so I can write this one as log x minus y whole square minus log, so phi square is 25, so 25 xy is equal to 0. So now here I can apply log m minus log n formula, which is log m by n, So that is equal to log x minus y whole square by 25 xy to the base 10 or anything to the 0. When I'll change this into exponential form, I'll get x minus y whole square by 25 xy is equal to 10 power 0, which is 1. So this I can write like x square plus y square minus 2xy is equal to 25xy. So this minus 2xy will transpose to other side. So we will get x square plus y square is equal to 25xy plus 2xy, which is equal to 27xy. So this is equal to divide both sides by xy. So if I divide both sides by xy, so what I'll get, x by y plus y by x is equal to 27. So this is what they are asking. So x by y plus y by x is equal to what? So x by y plus y by x is equal to 27. So this is our answer for this question. Next question. So what they are given in this question, if log 343 to the base 10 is equal to 2.5353, then the least positive integer n such that 7 power n is greater than 10 power 5. So first what they are given, They are given log 343 to the base 10, value 2.5353. So if I'll simplify this one, I'll get log 7 cube. So 343 means 7 sevens are 49, 49 into 7. So 343 to the base 10 is equal to 2.5353. So this, we know the formula log a power m to the base b is equal to m log a base b. M log a base b. So according to this, we can write 3 into log 7 base 10 is equal to 2.5353. So this is equal to log 7 to the base 10, we will get 2.5353 divided by 3. So let it be. So let it be this value. So let's see what they're asking. So this is what they're asking. Least value, least positive integer for n such that 7 power n should be greater than the 10 power 5. So let's we take let's we take 7 power n greater than 10 power 5. Let's we take 7 power n greater than 10 power 5. So if I'll take this one and apply log on both sides, if you'll take log to the base 10, we will take, because here we have 10. So to eliminate that, log to the base 10 on both sides, So if you'll take, what happens? So what happens this one? So log 7 power n to the base 10 is greater than log 10 power 5 to the base 10. So this we can write n into log 7 to the base 10 is greater than 5 into log 10 to the base 10. So both sides we apply formula log a power m to the base b is equal to m log a base b. So according to this formula, both sides simplified. So this is equal to, so n is greater than 5 by log 7 base 10, because log 10 to the base 10 is 1. So this is equal to n is greater than 5 by. So what we got the log 7 base 10 value here, see. So log 10 base 10 value, what we got is 2.5353 by 3. 2.53 by 53 by 3. So this is the value. So here this value is 2.5353 by 3. So this we can write like n is greater than 5 into 3 by 2.5353. So which is n is greater than 15 by 2.5353. So if you will simplify this one, so we'll get n is greater than 5.916 approximately. But what they're asking, the least positive integer. The least positive integer they're asking. The least positive integer of n. So this n value is here greater than 5.916 means what is the next integer, immediate integer you will get greater than 5.916 is 6. So n is equal to 6 is the answer. So this is the least positive integer which satisfies such that 7 power n is greater than 10 power 5. So this is the answer for this question, n is equal to 6. Next, let's see this question. So what is the question they are given here? If 4 power log 3 base 9 plus 9 power log 4 base 2 is equal to 10 power log 83 base x. 10 power log 83 base x. So let's see how to solve this. If you'll observe here clearly, here 3 we have, here 9. 9 means 3 square we can write. So here we have 4 and its factor we have here. So let's simplify that first. So if you simplify that, what we will get? 4 power log 3 to the base 3 square plus 9 power log 2 square to the base 2 is equal to 10 power log 83 to the base x. So I'm not changing the RHS. So first I'm simplifying only LHS. So here this particular, this and this. So how can we simplify? So we know that log a to the base b power m is equal to 1 by m to the log a to the base b, one formula. And another one is we can write log a power m to the base b is equal to m log a to the base b. So by using these two formulae, the first formula we are using for the first simplification power, second formula we are using to simplify the power of second term. So 4 power 1 by 2 log 3 base 3 plus 9 power 2 log 2 base 2 is equal to 10 power, we will get log 83 to the base x. Log 83 to the base x. So we know log 3 base 3 value is 1. So we know the value of this is 1 and the value of this is also 1. So what we can write next is 4 power 1 by 2 means it is the square root of 4 plus 9 square is equal to 10 power log 83 to the base x. So root 4 is 2 plus 9 square is 81 is equal to here for this RHS now. For this, I can use a power log n to the base b, which is equal to n power log a to the base b. So whenever I'm taking some formula for logarithm, here the bases always according to the definition, it will satisfy. So we can write this one is 83 power log 10 to the base x. So this LHS side 81 plus 2 is 83 and RHS will get 83 power log 10 to the base x. So 83 means here we can write 83 power 1. So here bases are equal. So powers we can equate. So powers also can equate. So if we equate the powers, so what we'll get is log 10 to the base x is equal to 1. So from here, if I'll change it to exponential form, I'll get 10 is equal to x power 1. So therefore, x is equal to 10 is the solution for this question. So next, question number 4. So what they are given question number 4, if log x base 2 plus log x base 4 plus log x base 16 is equal to 21 by 4. So what is the x value? So look at the bases. So in the first introduction of logarithm, I told very clearly, when you want to apply the formula for logarithm, so bases should be equal. First, we have to make the bases are equal if it is not equal. So let's do that first, our LHS side. So log x to the base 2, we cannot simplify further. So log x to the base 4, we can write 2 square plus log x to the base 16, we can write 2 power 4. That is equal to 21 by 4. So here for this term and for this term, so I can apply log a to the base b power m is equal to 1 by m log a to the base b. 1 by m log a to the base b we can apply here. So if you'll apply this formula, so what we'll get, log x to the base 2 plus 1 by 2 into log x to the base 2 plus 1 by 4 into log x to the base 2 is equal to 21 by 4 is equal to 21 by 4. So from these three terms, I can take log x base 2 as the common. So then what I will get? So what I will get, 1 plus 1 by 2 plus 1 by 4 is equal to 21 by 4. So this is what we'll get the in this step. So if we'll simplify this bracket, so what we'll get? So log x to the base 2 into, so LCM if I'll take 4 plus 2 plus 1 by 4 is equal to 21 by 4. So what we'll get in the next step? So log x base 2 into, this is a 7 by 4 is equal to 21 by 4. So 4 ones are 4 ones are 7 ones are 7 3. So you will get log x to the base 2 is equal to 3. So what you will get x when you will change to exponential form, 2 power 3. So x is equal to 8 is the value in this question. So next, question number 5. So what is the question number 5? They are given. So if log 2 base e into log 27 base e is equal to log 8 to the base 10 into log 10 to the base e. So this is what the question. So we have to find out the x value here. So let's we note down the question. First, what they are given: log 2 to the base e into log 27 to the base x is equal to log 8 to the base 10 into log 10 to the base e. So we know one formula: log a to the base b can be written as log a by log b to the any base c. So which is greater than 0 and not equal to 1. So like that we can take. So by using this, so how can we solve this? Log 2 by log e into log 27 by log x is equal to log 8 by log 10 into log 10 by log e. So if you look at this, these two gets cancelled and these two gets cancelled, right? So what you will get here, remaining is log 2 into log 27 by log x is equal to log 8. So this log 8 we can write like log 2 cube. So which can be written as 3 log 2. So both sides log 2 and log 2 gets cancelled. So remaining we can write log 27 to the base x is equal to 3. So log 27 to the base x is equal to 3. So when I will change to exponential form, so I'll get 27 is equal to x power 3. So this x is equal to, you will get cube root of 27. So therefore, x is equal to 3. So because this 27 we can write 3 cube. So cube and cube root gets cancelled. So x is equal to 3. X is equal to 3 is the solution. Next, question number 6. So from here, we are discussing about the inequalities. So how can we solve the inequalities problem? So let's see. So what is the first question they are given? So the number of solutions of log 2 power tan x to the base sin x greater than 0. So in the interval 0 to pi by 2. 0 to pi by 2. So both are having the logarithmic trigonometric functions. So when we'll take this question, log 2 power tan x to the base sin x greater than 0. So when we will change to exponential form, so the inequality sign changes. So that means it will become 2 power tan x is less than sin power x whole power 0. So anything power 0 is 1, we know. So 2 power tan x is less than 1. But in 0 to pi by 2, in 0 to pi by 2, 2 power tan x is not less than 1. So therefore, no solution. So number of solutions will be 0. Therefore, no solution. So therefore, number of solutions will be 0. Number of solutions. Number of solutions is equal to 0. So this is the way. So how can we solve this question? Next, let's see this one. So what they are given question here. So 1 plus log x square plus 1 to the base 5 is greater than or equal to log x square plus 4x plus 1 to the base 5. So this is one more question based on the inequality. So let's see how to solve this one. So first, before proceeding to solve this question, I will tell you one thing. So when you have in logarithmic inequalities, I'm talking about the base. If I have like this, log some a to the base 5 is greater than log b to the base 5. So whenever we are solving the inequalities questions, first we have to check the base. First we have to check the base. So why we have to check the base is, if base is greater than 1, So when you will convert this logarithm to exponential form, the inequality sign inequality sign inequality sign inequality sign not changes means directly we will get a greater than b. So then we can solve the problem. Second case is when log 5 when log a to the base 0.5 is greater than log b to the base 0.5, like this we have. So if you look at this question here, 0.5 means base is lies between 0 and 1. Base is lies between 0 and 1. So when base is lies between 0 and 1, when you will change this logarithmic form to exponential form, so normal equation, inequality sign changes. So here inequality sign changes, means if it is greater than, it will become less than. If it is less than, it will become greater than. So these two we have to remember while solving the inequality problems. So let's see this question here. 1 plus log x square plus 1 to the base 5 is greater than or equal to log x square plus 4x plus 1 to the base 5 we have. So here log 1 we can write like log 5 to the base 5, because I want to take all the bases are same. So 1 can be written as log 5 to the base 5 plus plus log x square plus 1 to the base 5 is greater than or equal to log x square plus 4x plus 1 to the base 5 we can write. So only the thing is I changed this 1 to the log 5 to the base 5. Now here I can apply log m to the base a plus log n to the base a is equal to log mn to the base a formula I can apply. So according to this formula, so next step will become log 5 into x square plus 1 to the base 5 is greater than or equal to log x square plus 4x plus 1 to the base 5. So just now we discussed before starting this problem, based on the base, we will solve the inequality. So base is greater than 1 here. This is greater than 1. This is also greater than 1. So there is no change in inequality when I'll remove the logarithm and change to normal algebraic expression. So 5 into x square plus 1 is greater than or equal to x square plus 4x plus 1. So this is what we will get. So next. So now simplify this one. So 5x square plus 5 minus x square minus 4x minus 1 is greater than or equal to 0. So this what will it will become 4x square minus 4x plus 4 is greater than or equal to 0, and x square minus x plus 1 greater than or equal to 0. So if you look at this one, so whatever you will substitute for all x belongs to R, this is true. It is true. So anything you will substitute, it will be either greater than or equal to 0. So this is the from this we got x belongs to all the real numbers. But the problem is not over. The problem is not over. Here, if you look at the question, so in the question, this we don't have any problem, because here we have square x square plus 1. So whatever you will substitute the x value, all the real numbers, you will get the positive values also. So minimum to minimum, you will get the 1. So minimum to minimum here get the 1, even though if x is 0. So log 1 to the base 0 is log 1 to the base 5 is 0. So that's not a problem. So logarithm value is defined. But if you'll see the right hand side, so here there is a chance of getting the negative also. So that's why, so we have to take the another condition that log x square plus 4x plus 1 to the base 5 is defined for when x square plus 4x plus 1 is greater than 0. So let's find out x value here. Let's find out the x value by using the quadratic equation formula. So minus 4 plus or minus root b square minus 4ac by 2 into 1. So this will get minus 4 plus or minus root over 16 minus 4 by 2, which is equal to minus 4 plus or minus 2 root 3 by 2, because 16 minus 4 is 12. So that can be written like this. So 2 and 2 gets cancelled in the numerator. If you take the common, you will get 2 plus or minus root 3. So when x is greater than x is greater than minus 2 plus or minus root 3 in the sense. So how we will take it here is x belongs to minus infinity to minus 2 minus root 3 union minus 2 plus root 3 to infinity. But what we got another answer, x belongs to R. So in these two solutions, what is the common solution? Common solution is this one only. So this one only the common solution, because between this to this value, that particular term, this term is not defined. So therefore, here how can we finalize the answer is x belongs to minus infinity to minus 2 comma minus root 3 union minus 2 plus root 3 to infinity, minus 2 plus root 3 to infinity. So this is the solution for this inequality question. So let's see the next question. So see the question. So what is the question they're given? A solution of the inequality log x square minus 4 to the base 0.2 is greater than or equal to minus 1. So what are the options they are given in this question is 1 less than mod x less than 2. Option B is 2 less than mod x less than or equal to 3. Option C is 3 less than mod x less than or equal to 4. Option D, you'll get 1 less than mod x less than or equal to 3. So let's see the solution for this one. What is the question they are given is log x square minus 4 to the base 0.2 is greater than or equal to minus 1. So I told you very clearly in the previous problem. So whenever we are solving the inequality questions, so first we have to check the base. So if you look at the question here, base is 0.2, which is lies between 0 and 1. So what I told, when base is lies between 0 and 1, so inequality sign changes. Inequality sign changes when logarithm 2 will change exponential form. So let's see according to this, so how can we write this? X square minus 4 is less than or equal to 0.2 whole power minus 1. So what happens, this one, x square minus 4 is less than or equal to 1 by 0.2, which is equal to 1 by 5. So that means we can take x square minus 4 is less than or equal to 5. So this can be written as x square minus 4 minus 5 is less than or equal to 0, which can be written as x square minus 9 is less than or equal to 0. So this is what we can write. So how can we simplify this one? So this we can simplify like x square minus 3 square less than or equal to 0, which can be written as x plus 3 into x minus 3 according to the formula a square minus b square. So now this is the final one. So how can we finalize from here onwards? Means we have one formula in inequalities, that one condition, if a less than b. So this is the provided condition. If a less than b, x minus a into x minus b is less than or equal to 0. So then x belongs to closed interval a comma b. So if this is like x minus a into x minus b is less than 0, then x belongs to open interval a comma b. So therefore, another way how can we write this one is x less than or equal to greater than or equal to a, less than or equal to b. Or this one we can write x less than b greater than a. So this is the condition in the inequality. This is the condition inequality. So according to this, so how to change this question is x minus of minus 3 into x minus 3 is less than or equal to 0. Less than or equal to 0. So here this is a, this is b. So we can write this one as x belongs to closed interval minus 3 comma 3. So this is the first set of solution. But the problem is not over. Problem is not over. So how can we continue this problem? I told you already, this term also affect the logarithmic values. So here there is a chance if I'll substitute 1 or 2 if I'll substitute, so this maybe get less than the 0 or equal to 0. So that's why we have to check the condition for x square minus 4 greater than 0 also. So for x square, another condition is here, x square minus 4 should be greater than 0. So from here we can write x square minus 2 square is greater than 0, and we can write this one as x minus 2 into x plus 2 greater than 0. So again, here we have conditions if a less than b, and x minus a into x minus b is greater than 0. So we can write that x belongs to minus infinity to a union b to infinity. So this is first one. If it is greater than or equal to 0, if it is greater than or equal to 0, so we can write the same set of solutions like minus infinity to a open to close union closed b to plus infinity open. So this is the condition when x minus a into x minus b is greater than 0. So let's say apply this here. So you'll get x belongs to minus infinity to minus 2 union 2 to infinity. So here we got the two solutions. One is x belongs to minus 3 to 3. Another one is x belongs to minus infinity to minus 2 union 2 to infinity. So how to match with our options? So if you see here, this is what the option what satisfies the answer what we got. So mod x is less than or equal to 3, and see mod x is greater than 2. So how it will matches here? Let's see here. This condition, just I'll make you to understand. So what is the option matching to our answer is mod x is less than or equal to 3 and greater than 2. So when you want to solve this kind of things individually, we can write mod x is less than or equal to 3. That means x is lies between minus 3 and 3. So which satisfy this one. And when mod x is greater than 2, so x is lesser than the minus 2 or x is greater than the 2. That means x belongs to minus infinity to minus 2 union 2 to infinity. So this is the way how we will solve this 2 less than mod x less than or equal to 3, and how it will be equal to our solution. So this is the way how we will solve this question. So let's see the next question. So what is the next question? So next question is log 6x minus 1, log 6x minus 1 to the base x is greater than log 2x to the base x, log 2x to the base x, then x belongs to, this is the question we have here. So if you'll see this question here, it is something different. So what is that something different here? Base, they are not mentioned any particular value. Base, they are not mentioned any particular value. So here base is simply they are mentioned some x, and what options they are given here is a minus 1 1 by 6 to 1 by 4 open interval, option B 1 by 6 to plus infinity, option C 1 to plus infinity, option D 1 by 8 to infinity, 1 by 8 to infinity. So in the previous problems, since base is mentioned a constant value, so we compare that with the basic definition. What is the base condition? Accordingly, we are solved. But here base is in variable. So how to do this? So one case 1, x greater than 1 for x greater than 1. Case 2, for x lies between 0 and 1. We are going to discuss this problem. So for x greater than 1, so very clearly 6x minus 1 is greater than the 2x. So from here 6x minus 2x, greater than 1 we will get. So from here 4x is greater than 1. So x greater than 1 by 4 we will get. And parallelly we have to check this also. That 6x minus 1 should be greater than 0. Greater than 0. So what will get 6x is greater than 1. So x greater than 1 by 6. This is one solution. So this is one. So here we have three conditions. One condition is x greater than 1, and for x greater than 1 we have discussed So we got x greater than 1 by 4, and here 6x minus 1 also greater than 0. From here we got the x greater than 1 by 6. And if you look at this 2x is also should be greater than 0. So x greater than 0. So this is for the first case. So comes to the second case. So here this is lies between 0 and 1. That means inequality changes, means 6x minus 1 will become less than 2x. That means 6x minus 2x is less than 1. So from where you will get 4x is less than 1, x is less than 1 by 4. So let's see what is the common solution for this all. So let's see the common solution for this all. So for that I'll take a real number line. So based on this, let's decide. And what we have here is 0, 1 by 6. We have 1 by 4. 1 by 4 we have, and even we have 1. So very clearly x is greater than 1 we have. X is greater than 1. One condition we have. So x is greater than 1. So here this is open interval. And x is greater than 0 also we have. X is greater than 0 we have. Here also this is open interval. And x is greater than 1 by 6 we have. And x is greater than 1 by 4 also we have. And what we have more is x is less than 1 by 4. So x is less than 1 by 4 we have. This is open interval. So if you'll see clearly, this is the common solution. 1 by 6 to 1 by 4 we have common values. So therefore, how can we finalize the x value series? X belongs to 1 by 6 to 1 by 4, and both are open circles. That means open interval we will get. So these were the set of solutions which satisfy this. So option A is correct. So x belongs to 1 by 6 comma 1 by 4. X belongs to 1 by 6 comma 1 by 4. So this is the solution for this question. So next, let's see the question number 10. So what is the question number 10 they're given here? What is the question number 10? So question number 10 is the solution set. Here it is the solution set. Solution set of the inequality. Solution set of the inequation log x squared to the base 2x plus 3 less than 1 contains. So this is the question we have. So let's see the solution for this one. What is the question they are given here is, question what they are given is log x squared to the base 2x plus 3 less than 1. So what are the options given for this question? So options given for this question, 0 to 1. Option B is minus 3 by 2 to minus 1. Minus 3 by 2 to minus 1. Okay. Option C, minus 1 comma 0. So option D, 0 comma 3. So this is the options. These are the options they are given. So let's see the question here, how to solve. So first, a very basic thing. This should be greater than 0. This is always greater than 0. So this is, since a square we have, x square is greater than 0. From here we will get x belongs to minus infinity to 0, union 0 to infinity, except 0. And very basic condition that 2x plus 3 not equal to 1. So that means 2x is not equal to minus 2. So x not equal to minus 1. This is one condition. So we got one condition here and one condition here. So next we can discuss here two cases. Case 1, if 2x plus 3 lies between 0 and 1. 2x plus 3 lies between 0 and 1. So when 2x plus 3 lies between 0 and 1, so what we'll get is, so if you'll add the minus 3 on both sides, minus 3 less than 2x less than 1 minus 3 is minus 2. Divide by 2. So I'll get minus 3 by 2 less than x less than minus 1. So this is one more condition we'll get. This is one more condition. So another thing what we'll get here is, when x is lies between minus 3 by 2 and minus 1. So here log x square to the base 2x plus 3 is less than 1 will become x square greater than 2x plus 3 when you will change it to exponential form. So x square minus 2x minus 3 is greater than 0. So if you will simplify this one, x square minus 3x plus x minus 3 is greater than 0. Factorize this one. So what we will get here? What we will get? So x common, x minus 3 plus 1 into x minus 3 is greater than 0. So you'll get x minus 3 into x plus 1 is greater than 0. So already in the previous questions, we discussed the condition for this one. So according to that condition, x belongs to minus infinity to minus 1, union 3 to infinity we will get. So what is the condition we used here? If a less than b, x minus a into x minus b is greater than 0, x lesser than the less value or x greater than the great value. That means x belongs to minus infinity to a union b to infinity, So this is the way we took this here. So this is the first condition. So what we got? Case 1. So let's see, the problem is not yet over. So if we'll draw this all on number line, whatever we got the conditions till now, let's finalize the answer for this. Then we'll go to the condition number 2. So what are the values we have here is minus 3 by 2, minus 1, 0, 3. So what we got the conditions here. One condition is minus infinity to minus 1, minus infinity to minus 1, open, 3 to infinity, Here it is open circles. And what is the another one we got? So x is lies between minus 3 by 2 to minus 1. So x is lies between minus 3 by 2 to minus 1. Both are open. And what we have, another one is x is minus infinity to 0, 0 to infinity, minus infinity to 0, and except 0, again 0 to infinity. So for this all, if you will see, this is only the common solution, minus 3 by 2 to minus 1. So from the first case, we got x belongs to open interval minus 3 by 2 to minus 1. So let's see the case 2. So what is the case 2 we have here? So if you'll see case 2, if the base is 2x plus 3, which is greater than 1. Base is 2x plus 3, which is greater than 1. So what you will get this one, 2x is greater than minus 2. So x is greater than minus 1. So this is one condition. So according to this condition, log x square to the base 2x plus 3 is less than 1. So how we will get is x square less than 2x plus 3 we will get. So x square minus 2x minus 3 less than 0. Just now we simplified this. Again, we are not going to simplify. We will get x minus 3 into x plus 1 is less than 0. From here, already we know the condition that if x minus a into x minus b is less than 0, so x belongs to a comma b, provided a less than b. So according to this condition, we can write this one as x belongs to minus 1 comma 3. So this is one condition. So, and we know that x not equal to minus 1 very clearly. So even you will not get minus 1 here because we have open interval. So from all, so we can finalize the answer as x belongs to minus 3 by 2 to minus 1, union minus 1 to 0, because 0 also not included here. So that's why this minus 1 comma 3, I'm cutting into two different intervals, minus 1 comma 0, union 0 to 3. So this is the final answer for this question. So next. So we have one question I'm writing here. So what is that question is? The question is, log. So what is the next question? Next question I'm writing here. If log x minus 2 to the base 0.1 is greater than log x minus 2 to the base 0.01, then the range of x. So option A, what they're given is 2 less than x less than 3. Option B, 4 less than x less than 6. Option C, 3 less than x less than 5. Option D, 0.01 less than x less than 0.1. So this is the given question. So how can we solve this question? See, already we discussed based on the base, we will solve the logarithmic inequalities. So let's we take the solution, question first, that log of x minus 2 to the base 0.1 is greater than log of x minus 2 to the base 0.01. So here bases are not equal first. So let's make bases are equal. So if we make the bases are equal, log x minus 2 to the base 0.1 is greater than log x minus 2 to the base, this can be written as 0.1 whole square. So we can write 0.1 whole square. So this is equal to log of x minus 2 to the base 0.1 is greater than log of x minus 2 to the base 0.1, it will become 1 by 2. According to the formula, log a to the base b power m is equal to 1 by m into log a to the base b. 1 by m into log a to the base b. So in the next step, what it will become? Log of x minus 2 to the base 0.1 is greater than log of root over x minus 2 to the base 0.1. So now look at the base. So base is lies between 0 and 1. So now base is equal to 0.1, which is lies between 0 and 1. So inequality changes. This is changes. So we will get x minus 2 is less than root over x minus 2. If you square it both sides, so if you will get x minus 2 whole square is less than x minus 2. So this is equal to what we'll get. So we'll get x minus 2 whole square minus of x minus 2 is less than 0. So from here x minus 2, if I'll take common, I'll get x minus 2 minus 1 is less than 0. So from here I'll get x minus 2 into x minus 3 is less than 0. So we know the formula very clearly because many questions are solved till now. So x belongs to 2 comma 3, or we can write this one as x is lesser than the 3, greater than the 2. So this is what the solution for this question. So option 1 is correct option. So this is the way how we will solve this question. And let's see one more question. Let's see one more question. Very simple. That question is in triangle ABC. In triangle ABC, log of cos A to the base 0.1 is greater than 1. Then A belongs to. So option A, minus pi by 2 to cos inverse 1 by 10, open interval. Option B, cos inverse 1 by 10 to pi by 2. Option C, all the real numbers. Option D, minus pi by 2 to 0. It is very simple question, very simple question. So what is the question is, log of cos A to the base 0.1 is greater than 1. So very clearly, your base is lies between 0 and 1. So we can write this one as cos A is lesser than the 0.1 whole power 1. So which can be equal to cos A is less than the 1 by 10. So from here, what we can say, your logarithmic function, since base is lies between 0 and 1, so it is a decreasing function. So here, since logarithmic function is decreasing function. Why it is decreasing function? So since its base is lies between 0 and 1. So since it is decreasing function, so we can take a is greater than cos inverse of 1 by 10. So that means a belongs to cos inverse 1 by 10 to, since cos is up to pi by 2 only, so up to pi by 2, this is greater than means cos inverse 1 by 10 to pi by 2. So option B is correct option. So these are the different questions in our daily practice problems video 2. So thank you all for watching and supporting to my channel. Kindly please subscribe to my channel, those who are not yet subscribed, and please enjoy the videos which I'm doing, and I'm going to do many videos based on the IIT with different kind of problems, starting from basic level problems to mains and advanced level problems. So thanks for your wonderful support. Please subscribe.